verify, you will find that c is equal to 1 over root 2, which is a value between 0 and 2, and so it ensures the relation that we're really speaking about. So this problem is a really, very nice one. It contains the proof of the Lagrange formula that we really was talking about. Now I will need to talk with you about the link between the different integration and the areas that we are evaluating. So he's giving you let f be an integrable function, okay, on a and b, and if a is greater than 0 in ab, then the area will be f of x dx equal to a. Actually, we found that if we integrate the function between the integration limits, so if I integrate the function f of x from 0 into a, it will give me this part, this area, okay, which is on one side of, with respect to the x of integration. And if we integrate from a into b to the same function, it will give you the area, or the area bounded between your curve and the x of integration. But as you can see, Mr. Muhammad, this is on the other side, so it has a negative sign. I can get rid of all of this, which part is going to be positive and which part is going to be negative, by considering the area in all times as an absolute value. And see when they are going to be added and when they are going to be subtracted, if it applies. If the areas are broken into pieces but on the same side, then I don't have to add and subtract. I will add them all. Okay? And that's actually what's explained in here. If I'm integrating f m greater than 0 from a to b, then it will give you a. If it is on the other side, it will be negative of a. Also, if you have f and g be integral functions on ab, and the k belongs to r, I can find from a to b f of x plus or minus g of x the general rules of integration in general. It will be applied also, it will follow up you with definite integration, which means definite integration can be distributed on sum or difference. A constant can be taken outside the definite integration sign. If f of x is less than or equal g of x, and then the areas enclosed by these values, by these functions, and the x of integration will follow the same rule as you can see. Also, if you are integrating from a to b and you need, for certain need, to integrate from a and c belongs to the interval between a and b, c is between them, I can integrate from a to c, then from c to b, as you can see. Also, if the limits of integration are the same number, the value of integration is going to equal to 0, because you will integrate and then you will substitute by the upper bound minus the lower bound, and they are exactly the same. So the result will be 0. If you change the integration limits, then the value of the integration will take negative sign, as you can see. So integrating from a to b, f of x dx is equal to the negative if you replace the limits of integration, and it's pure related to the substitution. In this case, I would need to evaluate from a to c, then from c to b. In this case, I can directly integrate from c to b. In that case, I will have to integrate from a to c, then plus from c to b. The differences will appear to you from the coming examples. If I want to integrate, for example, Mr. Omar, 3x squared plus 15 of x minus 3, but from 0 to 2. I can do that, of course. The first thing to do, or to cross your mind, is I need to be sure that this function doesn't cut the x of integration within 0 and 2. How to be sure about this, Mr. Muhammad? All I have to do is to find the zeros of this function. So I will start with solving 3x squared 15x minus 3 is equal to 0. So I will need to solve a quadratic equation, which is 3x squared 15x minus 3 equal to 0. I will need the general rule for evaluating the squares, and I already succeeded in this. So once you try to solve, you will find these are your roots. These are the points that the curve will cut the x-axis. It will happen once you try to solve it between actually this value, which is somewhere between the 4 and 6 with negative sign, and what I do care about, it's the 0.19 if you evaluate it, which is the positive root on the other side. Remember that I'm integrating from 0 to 2, from 0 to 2. And in this case, I have some space beneath the x-axis and another part above the x-axis, if I'm evaluating the area. But if I'm not evaluating the area, I will evaluate the whole integration, and it will give me the final result, or the difference between the positive and the negative areas. So once more, I will integrate, which is really simple. It's going to be x to the power of 3. It's going to be 15x squared over 2 minus u of x. And then I will start substituting, replacing every x by 2 minus replacing every x by 0. If I did this, the value is going to be 32. Okay, what if I'm going to break my integration in order to get the area? So I will take first from 0, in order to be sure about this area, from 0 to the root, okay? Once more, I will need, instead of working from 0 to 2, I will integrate first from 0 to 0.192, which is a root of this function. This part, the area that you are looking for, is beneath the x-axis. This is why I have added negative sign. And then plus, this is the area above the x-axis, which started from 0.192 up to 2. If you integrate the same integration rules, of course, if you integrate, just a second, if you make the integration, okay, of this problem, I think, I'm not really sure if I, just a sec, let me see. No. Okay, if you make the integration of this rule, which means I will integrate getting my function, which is x cubed 15 over 2x squared minus 3x, then substituting from 0 to 0.192, then substituting more by this area, there is a difference, not going to be 32. I believe this is going to be 36. The integration will come to 36 or something like this. I'm not really sure, just check. Okay? Just integrate and substitute. You understand what I'm saying? There's a difference between them. The difference, because, as I told you, this part is beneath the x-axis and that part above the x-axis. In order to make it more clearer for you, this is the x-axis and y-axis, and the my function is cutting the x-axis in this point. This point is 0.192, and that's the rest of our function. We are integrating from 0 to 2. So this part of area of integration will be added to that part. This is A1 and that's A2. The A1 part is this part. The A2 part is the other part. This is why it's going to be different. You understand what I'm saying now? Okay, this is really very good. Also, it will be the same case if I am dealing Also, it will be the same case if I'm dealing with this function. It is the integration from k minus 1 up to k plus 2 for 3x minus k to the power of 2 with respect to the x, and the k belongs to r from r. But this function, if you want to see how it's going to be, let's consider k equal to 5. For example, simplification, if I want to draw, Mr. Omar, k equal to 5, this is going to be the shape of your quadratic function. This is 5 and this is the shape. I want to integrate from 5 minus 1, which is 4, to 5 plus 2, which is 7. So actually, the area that I'm talking about is here. This is the area that we need to consider. Can you see it? Okay. Can you see it? See? This is the area that will be added. But the advantage of having these areas, they are both of them on the same side of your x. Both of them above the x-axis. In this case, integrating from the beginning till the end, it will be the same. So I can directly integrate x minus k to the power of 2, which is going to be very, very simple. This is, I will add to the power 2 to 1 and divide on the new power. So it's going to be k x minus k to the power of 3. I will replace x with k plus 2. Then I will replace x by k minus 1. It will come up to 9, as you can see. There will be no difference if you want to evaluate from 4 to 5. See? From 4 to 5, then from 5 to 7. So if I integrate it from k minus 1 to k, and then plus from k to k plus 2, it will be the same. You have the integration and the substitution and everything. And I believe I sent you this PDF, didn't I? I think I sent you this PDF from the WhatsApp. Please check. Okay. By this slide, I believe we come to the end of our lectures today. I will continue next time, inshallah. Thank you very much and enjoy your day. The next time you will have, I believe within the next week, you will have your second midterm. It's going to be on the 4th of May. I believe it's going to be on a Monday. I'm not really sure about the room yet. I will send it to you later. And if I have updates, I will send it to you also. I want you to know that the second midterm will cover all the topics between the first midterm till the integration by substitution. Till the integration by substitution. Till the time being, I'm not going to put the definite integration in it. Okay? But it will be for discussing the differentiability, the partial derivatives, the differential, how to find the directed derivative, starting for the anti-derivative, direct integration, till what I'm studying today, the integration by substitution. Going through integration by parts, integration by partial fractions, all of this have to be studied. Please go through them in the lectures, and inshallah the exam will be very easy job. It will be a written exam also, exactly similar to the one that we had previously with the same strategy and everything. Thank you very much, and we'll see you next time, inshallah. Thank you. Bye-bye.